Hi everyone, in this video, we're going to talk about the fluid flow measurement. Here is our example in this chapter. Water is discharged under a 400 centimeter head through a 0.6 meter diameter circular sharp-edged orifice at the side of a tank. If head loss is 32 centimeters and the coefficient of contraction is 0.73, determine the coefficient of discharge. Listing all the given, we get head is equal to 400 centimeters, also equal to 4 meters, diameter is equal to 0.6 meters, head loss is equal to 32 centimeters, also equal to 0.32 meters, and coefficient of contraction is equal to 0.73. Find coefficient of discharge. Coefficient of discharge is denoted by the formula C sub D equals C sub C times C sub V, where C sub C is the coefficient of contraction and C sub V is the coefficient of velocity. To solve for the coefficient of discharge, we first need to solve for the coefficient of velocity. Coefficient of velocity is denoted by the formula C sub V is equal to V over V sub D, where V is the actual velocity and V sub D is the theoretical velocity. Solve for actual velocity. Actual velocity is denoted by the formula E sub 1 minus head loss equals E sub 2. E sub 1 is also equal to V sub 1 squared over 2G plus P sub 1 over gamma plus Z1 minus head loss equals V sub 2 squared over 2G plus P sub 2Y plus Z sub 2. We can cancel V sub 1 since our system is open and there is no velocity on the surface. We can also cancel P sub 1 since there is no pressure, as well as P sub 2. We can also cancel Z sub 2 since our datum is on the Z sub 2. Now we get 0 plus 0 plus 4 meters equals minus 0.32 meters equals V sub 2 squared over 2G plus 0 plus 0. So with this equation, we get velocity is equal to 8.4972 meter per second. Now we solve for the theoretical velocity. Theoretical velocity is denoted by the formula square root of 2gh, where Vt is the theoretical velocity, g is the acceleration due to gravity, and h is head. So plugging in all the values, we get square root of 2 times 9.81 meter per second squared times 4 meters. V sub t is equal to 8.8589 meter per second. Now, after we solve for the actual velocity and the theoretical velocity, we can now solve for the coefficient of velocity, which is denoted by the formula C sub v equals V sub v over V sub t. Plugging in all the values, we get C sub v equals 8.4972 meter per second over 8.8589 meter per second, which is equal to 0.96. After we solve for the coefficient of velocity, we can now solve for the coefficient of discharge, which is denoted by the formula C sub D equals C sub C times C sub V. Plugging in all the values, we get C sub D equals 0.73 times 0.96, which is equal to 0.7008, and this is our final answer in this problem.